Here's a good one. We've all had a customer who's complained that their bath tap isn't as hot as the rest of the taps. Well, if you think about it, when you open a basin tap or your kitchen tap, you open the tap to the right amount of flow. If you put a basin tap on full, more often than not, it will splash over the edge of the basin. So on a 30 kilowatt combi, we're probably getting 12 litres a minute out of a basin tap. We're going to get a 35-degree rise. But when you open your bath tap, you tend to open it fully because you want to fill your bath as quick as possible. That same boiler, increase the flow rate to 14 litres per minute, we're only going to get a 30-degree rise, which is why the bath tap don't seem as hot as the rest of them. What's up guys, happy Sunday. Thanks for tuning in to my latest video. If you've not watched one before, it's basically a little insight into my working week as a plumber and gas engineer, seeing how I do things and hopefully me passing on a little bit of my knowledge and experience. Don't like to bore you with this talky bit I do at the start, but there's an important subject I wanted to talk to you about. Since I've been doing regular YouTube videos, I've been looking at my analytics more, and I've noticed that 99.9% of my audience is male. And this isn't about a male-female divide in the trades. I know a lot of very good, knowledgeable female gas engineers and female plumbers. It's not about that. This, what I want to talk to you about, only concerns the guys. So, testicular cancer is a massive killer in young men. And it's really important that you check yourself. I don't think enough people do. I just thought I could use my platform. I've got a lot of young guys watching me, to maybe remind you that after you've had a shower tonight, get your hand down there, right down deep into your plums, have a good feel, and just check for any lumps, any abnormalities, anything that wasn't there before, because it might save your life. Now, the most important thing, guys, is please don't do this while you're watching this video, especially while I'm making eye contact with you right now. But yeah, no shame in it. Get your hand down there, have a good squeeze, check them out. And if you find something, don't shit yourself. Just give your doctor, your GP a ring and get it checked out. So this job is a gas escape. It's a bit of a strange one. The tenants reported a smell of gas while they're cooking. So it could be anything, but I'm going over to check it out. And I just thought I'd show you this. So this is my leak sense pen from Kane. They don't make these anymore, but you'll probably recognise it. When I first started, we had something similar. It's old tech, but basically you turn it on. Always turn a gas sniffer on outside in fresh air. So once it's set itself up, you'll get that little beeping sound, and then the closer you get to a source of gas, it'll get louder and faster. And if you really pick up gas, the light will go red and it will start going real crazy. But they're not that accurate, and mine sometimes turns itself off halfway through. They have to go back outside and restart it. So I spoke to my mate Glenn from HeatSpec, and he's got this new tester which I'm going to try today. So this is it. It's got a flexible hose which probably makes it easy to get into some hard to reach spots behind cupboards and stuff. But basically it's a lot more detailed. Let's just turn it on and show you. So again, we have to turn it on outside in fresh air. Warms up for 25 seconds and then we're good to go. And this one gives you a display, a little graph, a digital screen. You can see it going up and down, the actual amount in parts per million per gas that it sniffs. Obviously this is more expensive than this one, but if it's more accurate, you know, gas is a serious thing, probably it's worth getting one that's more accurate. Now, number one question that I think you're all going to want to know. We're all professionals and gas is a serious business, but what would happen if you farted on the end of that? Would it pick it up? Well, we've all tried it. I've tried it. No, it doesn't on my farts. It might do on yours. If it does, I suggest you go and see a doctor. So, front left, you can't smell gas any other time, just when you're using it?
Yes.
And when it's been on for?
Yeah, so you shouldn't do it immediately, but it's when you've had it on for a little bit when you're cooking, when it's on full whack.
And then you can just start smelling gas?
Yeah.
Okay.
I mean, I was just thinking just don't use it. But...
When was the last time you used it?
I used it last night, but only briefly.
Okay.
Just to warm something up.
Whenever I'm at a job where I'm tracing a leak or a gas escape, I always have a chat with the customer first just to get as much information as possible out of them to give me a sort of clue as to what it might be. Now, because he only says he gets the smell of gas when he's cooking, my gut feeling is it's coming from one of these control knobs when it's in use. But before I turn it on, I'm just checking to see if there's any gas escape, just ruling out one thing at a time. So I've lit the front left one because that's the one he says he gets the smell of gas when he uses it, and then I'm just waving the gas leak detector around that knob in case any gas is coming up through the knob. So you can see we've picked up 1 part per million now. So what I'm going to do now is take that knob off and see if I can get the end of this probe in any closer. It's not a massive gap, but hopefully with the knob off we might read something else. But it doesn't really change. So the other thing I want to try is adjusting the knob, letting more or less gas through to the burner by twisting it, because it might be the action of twisting it is what lets the gas out. And you can see we've already jumped up to 4 parts per million. So I'm going to check underneath, remove the oven, and normally when you get called to a gas leak from a hob, it's something to do with the pipework underneath, loose nut, or they've not connected it properly onto the hob. So I'm just testing that just as a precaution, but I'm still convinced that it's coming from the control knob. So we've got 2 gaps at the front here which are lower, so I want to check there, getting my probe right in as far as I can. It's picking up a slightly bigger increase now. We're getting 8-9 parts per million, and the actual end of the tester illuminates red when it finds some gas, but it's still not a massive amount. Now I checked the gas pipe at the back, the connections, when I first took the oven out, but there is a bigger gap that leads through to the control knobs, and that's where the escapes come in. You can see here we've got the warning siren going and we're hitting 35 parts per million. So that's just showing me that's where the gas is making its way down and through. And this is a lot more accurate and something that I can show, record and show the landlord, the customer, rather than the pen, which is just an audible alarm and a flashing light. Bolt and braces, I just spray the pipework with my LDF spray just to give me an indication if there's a gas escape from any of these joints. I'm pretty confident it's coming from the control knob, because if it wasn't, if the gas escape was on the pipework, the tenant would smell gas all the time, not just when he was using it. And also there is a possibility that you've got the escape from the control knob and also a small escape from the pipework. 2 things on one job. Stranger things have happened. And then lastly, I'll just take all the knobs off and spray some LDFs directly on these gas valves, just because it would be nice to show the customer where it was bubbling up, just so they could see where it was escaping from, but unfortunately it didn't. Then last thing, fill out my paperwork, label this as immediately dangerous because it's a gas escape, isolate it, cap it off, and quote for a new hob. Right guys, this is going to be a mini technical video similar to the one I did on plate heat exchangers, where I drew out and did the basic heat flow principles. And it's about an equation I've got that you can work out flow rate, temperature rise or boiler output from your combi boiler just by knowing 2 pieces of these 3 bits of information. So if you've got boiler output and temperature rise, you can work out the flow rate. If you've got flow rate and temperature rise, you can work out the boiler output. And if you've got boiler output and flow rate, you can work out the temperature rise using this formula. Now, why is that important? Well, if you're working on a boiler and you've got, let's say, a 25 kilowatt boiler and you've got a specific flow rate, let's say 11 litres per minute, there is an actual figure of temperature rise that you should get from that boiler if you've got that and that. And if you've not got it, it means your boiler's not performing how it should. Also, when you come to quote, if you want if you've got a flow rate at that job, so the first thing you do when you're quoting for a combi boiler, check the flow rate. If you've got a flow rate and you want a temperature rise of say 35 degrees, then it will tell you what kilowatt output boiler you need to put in that property. So you can work out, if you've only got 11 litres per minute, there's no point putting in a 40 kilowatt combi because it's overkill. You don't need it. So it's good for stuff like that. I'm going to show you it now. We're going to have a couple of practices, and then the interesting bit is we're going to look at the figures that the manufacturer gives you, like on this Valent Ecotech Plus. We'll look at a 25 kilowatt boiler and the temperature rise and what flow rate that they specify you should get. So we're going to use the formula to prove whether these figures add up. So a 35-degree rise from a 25 kilowatt boiler, we should be getting 10.5 litres a minute. And we'll do that on a few different manufacturers. Okay, here we go. So if you want to work out your flow rate and you know your boiler output and your temperature rise, boiler output times 60 divided by temperature rise times 4.2 will give you the flow rate. If you want to work out your temperature rise, boiler output times 60 and your flow rate times 4.2 will give you your temperature rise. And if you want to work out your boiler output, your flow rate times 4.2 times your temperature rise divided by 60. This one's great for doing your boiler output. So if you're at a job, record your flow rate, record your temperature rise by putting your temperature probes on your cold in and your hot out, divided by 60, and that will tell you what your boiler's performing at. So we'll use this now, and I'll just show you the calculations by doing it with a couple of different manufacturers. We'll start with the Ideal. Okay, here we go. So we'll look at the 24 kilowatt boiler. So our output is 24.2. So that's a fact that we know. And we'll choose the temperature rise, so 35-degree temperature rise. So we're going to use those two figures, and we should get our flow rate of 9.9. So we're using this equation, boiler output times 60 divided by temperature rise times 4.2, and we should get a figure of 9.9. So the first one, boiler output times 60, so 24.2 times 60. Let's put it 24.2 times 60 is 1,452. 35-degree rise times 4.2 equals 147. So that's this top one here. Boiler output times 60, temperature rise times 4.2. Divide that. So 1452 divided by 147. We're looking for 9.9, which is what we get. So that checks out. Now we'll do it on a different manufacturer. So now we've got a main Eco Combi. Now, domestic hot water output, we've got a 25 kilowatt and a 30 kilowatt model. We'll do the 30 kilowatt, which is 30, and then we'll look at the flow rates up here for the hot water performance. On the 30, we've got 35-degree rise. We should get 12.3 litres per minute. We'll do it differently though. We'll use the 12.3 and the 35 to see if we can work out what kilowatt boiler this should be. So to work out what kilowatt boiler we've got, we need our flow rate, which is, what did we say it was, 12.3 times by 4.2 times by the temperature rise, which is 35 degrees. So 12.3 multiplied by 4.2 multiplied by 35 equals 1,808.1, and then we're dividing that by 60. So divide that by 60, and we're looking for 30 kilowatts. There we go, 30.135. Story checks out, main. So we've just proved that. Now this one's handy to look at because obviously boiler companies want to sell you boilers, and they will do that with marketing strategies. So you might hear about the new main Eco Combi. It can deliver you 14.3 litres per minute flow rate, and you might think, bloody hell, 14.3 litres a minute on a combi, that's great, but that's only at a 30-degree rise. If you look at the 35-degree rise, which is the industry standard, it's only going to do 12.3 litres per minute. So you have to be careful and really look into the figures that they try and sell you with. Imagine in the winter, your water's coming in at, let's say it's coming in at 5 degrees. A 30-degree rise on 5 degrees is going to give you 35-degree water coming out of your hot tap. If you were a customer and you had 35-degree water coming out your hot tap, would you be happy? No, you wouldn't. So you've got to look at things like that. Obviously in the summer, when the water's coming in at 15 degrees, you're going to have a 50-degree rise, which is acceptable. So there's things that you need to consider. But once you get this background knowledge and you know what's what, and you know how flow rates affect things, you're going to need to consider all this when you're sizing your combi boiler. Here's a good one. We've all had a customer who's complained that their bath tap isn't as hot as the rest of the taps. Well, if you think about it, when you open a basin tap or your kitchen tap, you open the tap to the right amount of flow. If you put a basin tap on full, more often than not, it will splash over the edge of the basin. So on a 30 kilowatt combi, we're probably getting 12 litres a minute out of a basin tap. We're going to get a 35-degree rise. But when you open your bath tap, you tend to open it fully because you want to fill your bath as quick as possible. That same boiler, increase the flow rate to 14 litres per minute, we're only going to get a 30-degree rise, which is why the bath tap don't seem as hot as the rest of them. Another useful one, if you're working on LPG, you can't gas rate an LPG boiler because you've not got a gas meter. But if you know your flow rate and your temperature rise, you can gas rate an LPG boiler using this equation. And this one blew my mind. Heat only boiler. If you know the boiler output and you know the temperature rise, so that's the differential between the flow and return, you can work out how fast the water is being pumped around your system. It's clever stuff. There's one more thing we need to speak about concerning this formula. This is for standard combi boilers running off a plate heat exchanger, cold coming in, hot coming out. It doesn't apply to boilers with flue gas heat recovery or with storage for hot water because that changes it slightly. For example, on this Intergas Extreme boiler that I fitted, it's got flue heat gas recovery, so it gives you boosted hot water performance. They've got lots of different figures here. So domestic hot water flow at 40 degrees, it can do up to 17 litres per minute. 55 degrees, 11 litres per minute. But that's because this boiler's got flue gas heat recovery. Something like a Worcester high flow, which has got a stored tank of hot water, it would be different for that as well. I think that's enough of that to be going on with. I don't want to confuse anyone. So I'd take a screenshot of that, use it on your next job, next time you're doing a boiler service, get a couple of the figures, work out what's what, and see how you get on. Now, all this information, the stuff I did on plates, I've got a special video coming out on heat flow principles with James Cox from Valent, where it goes into a bit more detail. Keep an eye out for that on my channel in the next week or so. This is another common call out you'll get. Got an unvented cylinder. Probably not this extreme. This one's been leaking. The water is completely soaked the floor. It's been dripping down onto that fuse spur as well. They've had to put a tub on that to protect it. But you'll see the water running through the tundish. Now, it's a very common fault because people don't get their unvented cylinders serviced, even though they should do every year with their boiler. Now we've got a big stored amount of hot water there. What happens when it heats up? It expands. So you have an expansion vessel to take up the expansion, and that's charged with air or nitrogen. When the air goes, all this water here expands, and because the expansion vessel can't take up the expansion, what would normally happen is the balloon would fill with the water, it would compress the air around it, and that takes up the expansion. Without the air there, there's nowhere for that expansion to go, so the safety valve, which is set at 6 bar on this, opens up and starts to let the water go safely to drain. Obviously this one's not going safe because it's running down the wall onto the floor. So to work on this, we turn the water off and open the tap, and that kills the pressure. But if you're replacing the expansion vessel, it's on the wall, it's full of water, it's above head height, it's heavy, it's going to be awkward to get off. So what I like to do, and I'm using the angled adapter on my inflator here because it's so close to the ceiling, is pump it full of air before you remove it. Now, what this will do is it will force all that water that's in there now out of the expansion vessel. So setting this to 3 bar, if we look at the tap, it's stopped, but when I turn the pump on, it's now going to force all that water out. It's going to come out the tap. Just leave that on until the tap stops, and then that vessel will be completely empty, easy to lift out. Right guys, really quickly, I'm going to do that bend that I did on the boiler job last week because a lot of people have asked to see it. It's going to be quick. I'm only going to use my bender, a piece of copper, and a pen and a tape measure. Nothing fancy. I'll just go through it the way I do it, that's it. Right, here we go. So, I want to do my step over, and I want to do it, let's pretend I've measured it on the job, That's where I want it. So I'll always start with that bend first, because that's the most difficult bend. There's no point doing the easy bits and then messing up on the most difficult bit. You've wasted a piece of copper. So pop that in the bender. And it's going over that gas pipe, so I want it to be about 60 degrees. So about there. Quite a tight bend. So I'll get my hook as close as I dare get it. And then just line up. Just looking at that now. And then pull my first bend, which I want it to be about there. Can you see that? And then whip that out. And all I'm going to do is offer it in the other way. And I'm going to look at it. Imagine there's another piece of copper going there. Again, eye it up so it's straight. Pull that bend. So that's my step over done. So that's the most difficult bend done. And then from there, let's say I wanted it to start, I don't know what we got here, 300 mil away from my step over there. In fact, let's come a bit closer. Let's do it 200 mil. So that's where I want it to. I'm going to kick across, kick back up, and then we're going to step out again at the top. So from there, and then you just got to again eye it up so it looks right. And then we're going to come across. Forgot to tell you the measurement. Let's say we're going to come across, what should we do? Let's do 150. So that looks about right to me on a 45-degree angle. So that's my step over now, and we've kicked off to the side. And this is where actually we've got another piece of copper ready. Let's put that in. So with that in the bender now, I want to come back this way, but I want the distance to be 150. So what I would normally do is offer a piece of copper in. Let me go and get a piece of copper. So offer a piece of copper parallel to the one we're bending. 150 I want, that's 110 at the minute. So a little bit further. This one's 30. Right, 150 there. Again, look at it. Make sure it's straight. And then we're going to bend that and then just spy eye. Make sure that's parallel. So that's our third, what's that? 1, 2, 3, fifth bend. So we've got to step over, we've come across, now we're going to kick out. I've not left enough room on the pipe, but we'll do it anyway. there, and then we're going to kick out. Don't think I've left enough room. I might just get it. Do that again. This might just damage the end of the pipe. And I'm just looking, making that parallel with that one. Hopefully we've not damaged the end. And then look at it. If it's not quite right, which I think that's pretty spot on, you can always give it a bit of adjustment on your knee. But, I'll move the camera now, we'll look at it. But so there's my step over. That steps over my gas pipe, comes across to where I want it to go, comes up, and then it steps out again to go into the pipe above. Let's see if I can stand there and show you that. Where's the camera? I know it's not a tutorial, I'm just showing you how I do it, but yeah, that's that. I'll put it on the floor now and you can have a look at it. So that's the finished bend. I've got the step over and then it kicks out dog leg. Probably not the easiest method to follow, but that's the way I do it. Just with the bender, pen, tape measure, and then probably the most important bit, the way I bend, is the spare bit of copper. I don't think I'll be able to do it without that. And yeah, that's it. Thanks for watching.
Hi guys, my name's Jay and I fucked up. About 12 years ago, when I was an apprentice, I was sent to go and fit a boiler with the chap I was working with. Now, the first couple of weeks that I was into my apprenticeship, we've been working on site and it's quite cold and you obviously have to wear steel toe caps when you're on a site. You should wear them every day, really good practice. So I sort of carried that on to this job, this boiler change. The only thing was, because it was cold and everyone on site had rigger boots, I thought, you know what, I'll buy myself a pair of rigger boots. So I had those and was wearing them in the customer's house. So we finished a job, done the boiler change, filled it up, it was fired, everything. And the guy I was working with said, jump up in the loft, mate, and just self-tap the flue. I'd seen him do it before, so went up there with the drill, self-tapping the flue, but obviously got my rigger boots on. And when you're an apprentice, you don't really know what you're doing, do you? So I was drilling into the flue with the self-tapper, with the 3mm drill bit to put the self-tapper in, and I was pressing too hard and snapped the 3mm drill bit. As I snapped the 3mm drill bit, I shot forward off the floor joist, well, off the roof joist, sorry. And obviously, your natural instinct is to step as you sort of lunge forward. So I stepped off the floor joist, off the roof joist, sorry, and put my nice size 10 rigger boot straight down through the ceiling right next to the bloke's head who was commissioning the boiler, just as our boss walked up the stairs to see how we're getting on. Now, he didn't sack me, which I was quite surprised. He gave me a right dressing down in front of the customer, and I was like, yeah, really sorry, first few weeks, blah 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 blah. Anyway, I was fitting another boiler with another guy. About a month later, we had all the floorboards up in the bedroom, fitting it in the airing cupboard, and I stepped off the floor joist, stepped backwards, and I went straight through the ceiling into the living room below. Yeah, you can imagine that phone call to the boss 3 weeks after I'd done the first one. Not good. Surprisingly enough, he didn't sack me, but you know, guys, we all make mistakes and you learn from them. So hopefully 13 years on now, I'm doing all right. So take it steady. And if you don't follow me, Plumber J on Instagram. Stay safe, guys.
Touch wood, I've got this far in my career without putting my foot through a ceiling, but I know a lot of guys, especially young apprentices, who have done it. So nice one, Jay, for sharing that story. The worst one that I know about was a plasterer. It was a job that I was on, but I wasn't there that day on site. They took all the flooring out and it was literally just joists, and he was stepping across, lost his footing, and he went through. His arms went up in the air and he dislocated one shoulder and cracked his collarbone in 2 places on the other shoulder. Sound horrible. The fire brigade had to come and get him out, and he was off work for probably 6 months, I think. Couldn't lift his arms above his head. So yeah, be careful when you're stepping between joists, especially in roof spaces.